of you. This is O.Sailaja, Department of Chemistry, K.B.N College, Vijayawada. Today I want to discuss about the conformational analysis. Conformational analysis. Conformational isomers is a form of stereoisomers in which the isomers can be interconverted just by rotation of carbon-carbon single bond. Conformational isomers are the isomers which are converted into the one form to another form by simply rotation of the carbon-carbon single bond. While any two arrangements of the atoms or molecules that differ by rotation about single bonds can be referred to as the different conformations. Conformational isomers have the same molecular formula, but the spatial arrangement of the atoms or the molecules are different. These isomers are termed as a conformational isomers. The energy barrier must be small in conformational isomers to occur. There are several types of conformational isomers. For example, ethane, butane, propane, cyclohexane, etc. Conformational isomers can be written by the Newman projection formula. In this Newman projection formula, one carbon is represented as a back carbon and it is denoted as a circle, and a front carbon is denoted as a Y. Conformations of ethane. Ethane is an organic chemical compound. It is a colorless and odorless gas at standard temperature. Ethane molecule consists of 7 sigma bonds. There will be a change in the shape of the molecule by the simple rotation of the carbon-carbon single bond. But many possible differences occurs when there is a rotation about the carbon-carbon bond. Mostly ethane can be existed as a two conformational isomers. One is the staggered form, another one is the eclipsed form. This is the staggered representation and this one is the eclipsed representation. Staggered representation is more stable than the eclipsed representation because in staggered conformation the gap between the atoms is 60 degrees, but in the eclipsed conformation the difference between the atoms is the 0 degrees. So this here in the eclipsed conformation steric repulsions are occurs compared to the staggered conformation. So staggered conformation is more stable than the eclipsed conformation. This is the conformational representation of the ethane, staggered conformation and eclipsed conformation. By the rotation of the carbon-carbon single bond, the staggered conformation is converted into the eclipsed conformation. And this is the energy profile diagram for the representation of the ethane. Here staggered conformation and eclipsed conformation. Staggered conformation have the low energy and more stable, and eclipsed conformation has the high energy and less stable. Their barrier to rotation between the conformation is small. The most stable conformation of ethane is the staggered conformation having the less energy. The least stable conformation of the ethane is the eclipsed conformation and have the high energy. Next, conformation of the simple propane. A similar analysis can be applied to the propane as well as the ethane. There are still two types of conformations are existed. Here also propane exists as a two conformations, that is the staggered conformation and another one is the eclipsed conformation. Compared to the eclipsed conformation, staggered conformation is more stable than the eclipsed conformation. The difference between the propane and ethane is that there is the methyl group connected to rare carbon of propane. The staggered conformation is more stable and having the less energy. Okay, this is the conformational representation of the staggered form and this is the conformational representation of the eclipsed form of the simple propane. And this is the energy profile diagram for the propane. Here staggered conformation have the low energy and it is more stable than the eclipsed conformation. Eclipsed conformation have the high energy and compared to the staggered conformation this form is the less stable. And next we go for the conformations of the butane. Butane is an organic compound which consists of a alkane with the 4 carbon atoms. The difference between the butane and the propane is the one CH2 group extra in the butane. It may be referred to as a 3 isomers. By simple rotation of the carbon-carbon of the simple butane sigma bonds, we can observe 3 types of conformations. One is the antiform and second one is the gaseous form and last one is the least stable eclipsed form. antiform is more stable than the eclipsed conformation. Gauge conformation is more stable than the eclipsed conformation and less stable than the antiform. Butane can exist as a three conformers, that is the antiform, gauge form and eclipsed form. By simple rotation of the carbon-carbon sigma bond by 60 degrees rotations, antiform is converted into the gauge form, and next we convert to 60 degrees, gauge form is converted to the eclipsed form. And this is the energy profile diagram of the simple butane. Here this is the gauge form and this is the antiform and this is the eclipsed form. Eclipsed form has the high energy, so it is a less stable, and here gauge conformation have the high energy comparative to the antiform and less energy comparative to the eclipsed form, so it is a less stable than the antiform and more stable than the eclipsed form. Here antiform is more stable than comparative to the gauge form and the eclipsed form, because antiform the two methyl groups are in the two different opposite directions, so there is no steric repulsions are present, so antiform is more stable than the simple gauge form as well as the eclipsed conformation. And next, coming to the Baeyer strain theory. Okay, this is the most important theory based on the following assumptions and postulates. An alicyclic ring having all the carbon atoms lie in the same plane. All the carbon atoms in the alicyclic carbons are present in the same plane. Hence, one pair of the bonds cannot assume the tetrahedral angle, that is the 109 degrees 28 minutes. Any deviations of the carbon-carbon bond angle, the ring formation of ideal tetrahedral angle develops a strain of the ring. Any deviations are present in that forms, there will be a strain in present. Such strain is called the angle strain, which makes the ring unstable. More the strain, less will be the stable. Greater the angle strain of the ring, the more unstable the ring. The angle strain develops the ring due to the deviations from the regular tetrahedron. Angle can be termed as a valence angle deviation D. D can be calculated by using the formula 109 degrees 28 minutes minus alpha by 2, where alpha is the bond angle of the corresponding cyclohexanes. This is the simple cyclopropane and this is the cyclobutane and this is the cyclopentane. Here alpha is the 60 degrees, here angle is the 90 degrees, and here cyclopentane angle is the 108 degrees. Next, when ring size increases, strain will be decreases. Here in cyclopropane, the bond angle is the 60 degrees and the angle strain is the plus 24 degrees 44 seconds. And here in cyclohexane, the bond angle is the 120 degrees and the angle strain is less. When the ring size increases, strain will be decreases. Conformations of the simple cyclohexane. Cyclohexane is a alicyclic compound and it can be exist as a four conformations, that is the chair conformation, twist boat conformation, and half chair conformation. The stability order of cyclohexane is the chair form is more stable than the twist boat and half chair. And next, the chair conformation of cyclohexane is more stable than the remaining forms, that is the twist boat and half chair. Here there is no strain between the or no steric repulsions present in the chair form. So chair form is more stable than the remaining three forms, that is the twist boat form and half chair form. Here boat conformation, it has no angular strain. However, in addition to the torsional strain resulting from four polar interactions or four hydrogen interactions are present. In boat conformation, first carbon and fourth carbon, the hydrogen repulsions are present. So this is less stable than the chair form. And next, twist boat conformation, it is a more stable than the boat conformation but less stable than the chair conformation. The flagpole interactions and torsional strains in the boat conformations are very reduced compared to the boat form. And this is the energy profile representation of the simple cyclohexane. Chair form has the less energy and it is more stable than the half chair, boat and twist boat. And twist boat have the less energy comparative to the boat form and half chair. So it is more stable than the comparative boat form and half chair form. And compared to the boat form and half chair form, boat form have the less energy comparative to the half chair form. So boat form is more stable than the half chair form. In half chair form, there is a torsional strain, steric repulsions are present. So half chair form is less stable than comparative to the remaining chair form, twist boat and half chair form. Next, conformations of the monosubstituted cyclohexane. The two conformations of the monosubstituted cyclohexanes are axial forms and equatorial form. In axial form, there is a steric repulsions are present. In equatorial form, there are no repulsions are present. So, diequatorial forms is more stable than the diaxial forms. Thank you.